everyone. I recently got very interested in this Bezier curve construction on Wikipedia. So this also showcases some exercises or examples in parametric calculation of these curves. Here you can see kind of interpolation, linear interpolation between 2 points. And when we have quadratic curves, as in the case of an arc, for instance, you are actually interpolating between 3 points. And this t parameter is basically used to animate how that point is calculated. So I wanted to show you using Grasshopper how this could actually be visualized with native Grasshopper tools. So I'm actually going to start with 2 points so that we can also cover some basics. So imagine we have 2 points like this. So I'm going to just link them up to my script. So how do we linearly compute between these 2 points? So you can do this in a bunch of ways. Imagine you have a line and you can basically evaluate a point between these 2 points along the line. So you can simply do evaluate curve, or you could do point on curve. So these are essentially the same things, but when you're using point on curve, this basically takes a parameter from 0 to 1. Think about it almost like percentage, right? So we're covering how much we want to move from point A to point B. The evaluate curve actually does this the same way, but the reason why I'm going to use this is because it has the t parameter. Now the t parameter could be associated to the distance between these 2 points, or it could simply be represented as a percentage as well. So in order to do that, you need to right click here and reparameterize the curve so that once you use it, let's say you want to find the midpoint, 0.5 would evaluate the midpoint between these 2 points. Now, what is actually happening behind the scenes? So if you want to look at some vector calculation, let's draw a vector between these 2 points. So this was our starting point. This is A to B. Now, if you want to display that vector, a vector is basically a direction with a magnitude, right? So that will become an arrow. Now, in order to get to the midpoint here, what we need to do is basically take half of this vector and add it to the location of the first point. So you can simply do it by dividing the x, y, z coefficients of this vector and add it to the x, y, z of the reference point, right? So let's look into that. So we can deconstruct a vector, and we can also deconstruct a point. So this is our x, this is y, and these are the x and y of our vector. So I'm going to basically divide them by some coefficient. Let's say in this case we're doing, we're trying to find the half point. Now if I add these values to x and y and construct a new point along these x and y, that will be exactly the same midpoint. But the way this is calculated, of course, it's kind of limited, right? So we need to, there are also other ways we can do it. For instance, change the amplitude of this vector, normalize this vector, or use its length to multiply it with some coefficient like this and do the addition. So that will basically give us kind of the same location, but this is kind of simplified version of it actually. Now I'm going to use this logic to actually show you how the Bezier is done. So I'm going to disable this part of the code now and add one more point. So let's say we want to go from this point to this point, but there's a third point here. And now we are going to do a quadratic Bezier. So the way this computation works is you basically try to go from A to B. So this is A, this is B, this is C. So we can go it in a linear fashion by some coefficient. So this would be our first interpolation. And we're going to do the same thing from B to C using a line. And we're going to do the same interpolation there, but use the same coefficient. So you can see that these 2 points are now moving in the same percentage, right, along these lines. Now what we're interested in is a third point, basically between these 2 points that are changing. And we need to evaluate the same t coefficient there. So this point would basically be on this arc here. So if you basically move the parameter from 0 to 1, you can see how that point is moving. And that animation is basically what we see on the Wikipedia page. So we can also connect this to a range, and range automatically divides zeros and ones. So I'm going to assign this parameter to a number container. And what we could do is divide 0 and 1 into 50 steps. And if I connect this, now you can see how that arc is constructed, right? So all of these points are basically calculations of these interpolations. So we can increase or reduce the number of steps, but you can see we are basically simplifying the information of how many points we want to compute or interpolate between these 2 points. Now I'm going to take this one more step further and add a 4th point. Let's add it in a different way. Since these are linked, I'm actually going to rotate them a bit and add the 4th point here. So I'm going to add one more point, and this would be a 4-point Bezier now. So I'm going to go from the 3rd point to the 4th point now and do the same type of derivation, right? So I'm going to basically make another interpolation here, and let's actually connect only a single parameter for now. Let's do 0.5 so that this would be easier to visualize. So I'm going to make another copy from here to here, and between these 2 points I'm going to make another interpolation. So this point is now on the curve that interpolates between these 4 points. So if you move, you can see how that is computed. So all of these percentages are basically recalculated. So basically this is, I think, a cubic Bezier. A cubic Bezier is basically interpolating between these 4 points. And you basically have, how many did we have? We have 3 lines here that are connecting the first points. And then we have 2 lines here, the kind of first derivative. And then the second derivative is basically connecting these 2 lines, right, with the same interpolation. If I put in more points, these will be the interpolated Bezier now. And I'm going to increase the point count. You can see we have we get a lot of lines emerging. And if you simply interpolate between these points, that will basically be our NURBS curve. So I want to show you how you can also build these parametric Beziers in Grasshopper that kind of look like the animation in Wikipedia page, but I hope this was fun. You could also do this for a bunch of 2D graphical applications, so you can also use this for some sort of artistic purposes. I hope you like this video on Beziers. Thanks for watching.